Okay, this is lesson 10.3, and we're going to talk about factoring. So in the previous lesson, we talked about multiplying, and now we're going to talk about undoing multiplication, and it's called factoring. Your aim today is that I can factor polynomials using a greatest common factor or the GCF. And you've used these before in middle school, okay? So factoring expressions is one of the gateway skills that's necessary for much of what we do in algebra for the rest of the year. Factoring is going to come into play into every unit we have following this, so this lesson's really crucial to understand. So we've got two meanings of the word factor. The first meaning is what we're going to talk about today, okay, and that's using it as a verb. So when I say that I want to factor something, I'm saying that I want to rewrite the expression as a product. So in other words, I might have something like, x squared plus 5x plus, actually let's change this to say x squared plus 5x plus 6. I can rewrite this expression as x plus 2 times x plus 3. And you see I've taken something that I'm adding together, and now I'm turning it into something that you multiply. So this is what factor means. So I've turned this expression into a product where I'm multiplying. That's what definition number one means, to turn an expression into multiplication. So this is our goal today, is for us to be able to go towards this idea, okay? And the second definition of factor is the noun. And you guys have seen this a lot before. A factor is an algebraic expression that is one part of a larger factored expression. So for example, I've got the number 12. 3 times 4 is 12. 3 is a factor and 4 is a factor. But we're going to learn today how we can take a factor involving letters. So you're great with factors of numbers, but we also can have factors when we're involving variables and exponents. So let's take a look at exercise 1 to start this idea of factoring. Exercise 1 says, consider the expression 6x squared plus 15x. Write the individual terms 6x squared and 15x as completely factored expressions. Determine their greatest common factor. So when we say completely factored expressions, in other words, we're saying expand. We want us to expand all of the factors of 6x squared. So I know that 6 is 2 times 3, and x is x times x. So this is the first step of expanding. I know that 15x is 3 times 5 times x. Okay, I can't break up the 3 and the 5, the 2 and the 3 anymore. Okay? Now I look for what do they have in common. Okay? So what's in common? This is how you find the common factor. What do they have in common? Well, they have a 3 in common, they each have a 3, and they each have an x in common. So I can say that my GCF, my greatest common factor, is 3 times x. I write it as multiplication. The 3 and the x as 3x, because that's what they share. Okay? So now letter B, I'm going to take this idea to letter B, use the distributive property, rewrite 6x squared plus 15x as a product. So remember how I used the box method to kind of show you guys how to multiply? Well, we're going to use the box method, but we're going to use it in reverse now. So I know that I have 3x here. This is my GCF. I'm going to put it here on the side of my box. 3x. And I know that I've got a 6x squared and a 15x in here when I multiply it out. The question is, what's the other factor that would go up here? So you ask yourself, okay, what do I multiply by 3x to get 6x squared? Well, 2 times 3 is 6, and x times x is x squared, so it has to be 2x. The 15, what times 3 gives me 15? 5, and what times x gives me x? Just 1, but it's invisible. So I can rewrite my product as 3x times 2x plus 5. The other way you can do this, and I think this is easier, but I'm going to show you both ways because I want you to figure out what works for you. I know that my GCF was 3x, right? So my GCF is 3x, so I know that I've got 3x as one factor. The other factor is, I'm going to erase this arrow here. The other factor, what goes in here, is what's left over. So here's what's left over for the 6x, 2x. So that goes there. And what's left over here is a 5. So do you see how I still got the 2x plus 5 both ways, either doing the what's left over way or doing the box method way. So this one is the box method way, and this is the leftover method way. Either way to find your factored product works for me. Okay, we're doing more practice with this in this lesson so you can get a better idea. Letter C says evaluate both 6x squared plus 15x and the factored expression you wrote for x equals 2, and what do you find? So my original expression was 6x squared plus 15x. And my new expression is 3x times 2x plus 5, right? I took this and I factored it. They're saying now plug in x equals 2 and see if they're equivalent. This is how we check our work, right? We're going to plug in a number and see if they're the same. So I'm going to have 6 times 2 squared plus 15x times 15 times 2, and then 3 times 2 times 2 times 2 plus 5. Okay? And now we're going to see if it's equivalent. This becomes 6 times 4 plus 30. 24 plus 30 gives me 54. So when I do it with this first one, I get 54. 3 times 2 is 6. 2 times 2 is 4. And 6 times 4 plus 5 is 9. And 9 times 6 is 54. So we factored correctly when we plug in an x value. So these two things are equivalent, which is what we want. Okay? So let's do some more practice with this because this is a pretty overwhelming lesson and I want to make sure that we're feeling good about it. So let's take a look at exercise 2. Okay, so it's really important that we're fluent in this idea and reversing this distributive property, right? Either the box method or the leftover method. So exercise 2 is practicing this what we did in exercise 1. So exercise 2 says for each of the following sets of monomials, identify the GCF of each. Write each term as the extended product. So for these 6 examples, we're just finding the GCF. We're not going to find the whole product, we're just finding GCF. So what I like to do for this is I like to extend each one. 12 is the same as 3 times 4, but can't I write 4 as 2 times 2? So when I extend 12, I'm going to write it this way with prime numbers. 3 times 2 times 2, and then I've got 3 x's. Okay? For 18x, 18 is the same thing as 9 times 2, but isn't 9 also the same as 3 times 3? So I'm going to write 18 as 3 times 3 times 2, and then 18x has just 1x. Now I'm going to circle what they have in common. So they have a 3 in common, they have a 2 in common, and they have an x in common. So my GCF for these two expressions is 3 times 2 times x, which would be 6x is my GCF for part A. Okay, let's try letter B. Actually, let's go to C and you can try B on your own. I'll pause. So I'm going to go do letter C. Okay, so same thing, 21x squared y to the 5th. I've got an extra letter in here. 21 is the same as 7 times 3, so I've got 21. I've got 2 x's. I've got 5 y's. So I'm going to write times y. So I'm extending that product. 14x to the y to the 7th. 14 is the same as 7 times 2. I've got 1x, because there's an invisible exponent of 1. And I've got 7 y's. 1, 2, 3, 4, 5, 6, 7. Okay. Now I look for what they have in common. They have a 7 in common, so I circle it. They have an x in common. They have a lot of y's in common. Look how many y's I'm having to circle. They have 5 y's in common. Okay. So when I write my GCF, I'm going to say, okay, it is 7 times x times 5 y's, which simplifies to 7x y to the 5th as my GCF for problem C. Okay. All right. Letter E. I'm doing this out of order because I want you guys to try the rest on your own and pause it. So I'm going to do letter E. So now I've got 3 different So I'm going to do each one. So 20x to the third is the same as 10 times 2. But can't I simplify 10? What would 10 be? 5 times 2? So this becomes 5 times 2 times 2. So that's what I'm going to write. I'm going to write 5 times 2 times 2. And then I've got 3 x's. Okay? Negative 12x squared. Now, a negative number for the GCF, the negative number comes into play when we come to put it together with a product. So because this 12 has a negative in front, we're just going to make the first factor negative. So I know that 12 is negative 3 times 4, but keep in mind again, 4 can be written as 2 times 2, and I always want to keep it in lowest terms, so I'm going to put 2 times 2, and then I've got x times an x. Okay, so a negative number, just always put a negative as the first factor you put. It doesn't really matter which one, because any of them could be negative to make that a negative number. And the last one is 28x. That's the same thing as 7 times 4, but we're going to rewrite this 4 as 2 times 2, like usual, so this becomes 7 times 2 times 2, and then we just have 1x here. The process for finding GCF is the same for 3 terms. It just means you're looking for what all 3 have in common. So all 3 have a 2 in common, they also have a second 2 in common, and they have an x in common. Okay, they have nothing else in common, so my GCF is 2 times 2 times x, which simplifies to 4x. Alright, now I really want you guys to pause the video here, and I want you to try B, D, and F on your own. When you unpause, I'm going to show you the full solution, so it's a really good idea to try this first and not just copy it down. Because this is, again, like I said, a really important skill, and the answer key does not have the work shown. So take a minute, pause, and try B, D, and F on your own. Alright, so I've done letters F and B and D with the correct solutions. B, your GCF is 5x. For D, your GCF should be 8x. D was a little tricky because you had a lot of 2's that you had to reduce. You couldn't just write 8, it had to be 2 times 2 times 2. So they each shared 3 2's to give you 8x. And for F, they only shared a 9, an x, and a y to give you 9xy. So this is finding a GCF of polynomials. So now let's put that together, the GCF of what we did in exercise 1, where I showed you these 2 ways, the leftover method and the box method way. So let's practice putting those 2 things together in exercise 3. So once you can identify the GCF of a set of monomials, you can easily use it and the distributive property to write factored expressions. So we have to find the GCF first, and then we put it together to find the product. So for exercise 3, write each polynomial as a factored expression involving the GCF of the polynomial. So the first step to do, and I'm going to move this down a little bit actually, so I can show you. So your step 1 is to find your GCF, and then step 2, use the leftover method or box method to write your product. Okay? So exercise, letter A, I'm going to find my GCF. So 6x squared is 2 times 3 times x. 10x is 2 times 5 times x. Now look for what they have in common. They have a 2 in common and an x in common. So my GCF is a 4x. Okay? Now, to write what my expression is, I'm going to use the leftover method because that's one of my favorite methods. What's left over? Well, first, actually, let's write this out here. So I'm going to do 4x and then parentheses because I remember I want this product. So I have 4x as my GCF, and then whatever's inside is what's left over. So first, I'm going to look at my 6x squared. I have a 3 and an x left over, so 3x. Oops, wait, sorry. My GCF is not 4x. Let me just fix this. Sorry, guys. My GCF is 2x. I wrote 4 and it should be 2. My mistake. So, my GCF is 2x. What's left over on top with the 6x is my 3x. And then what's left over with 10x is a 5. So this becomes plus 5. Now if you check your work here and distribute, right, what's 2x times 3x? 6x squared. That's what we want. That's what we started with. What is 2x times 5? 10x. That's what we had, 10x here. So your final answer should work with your original expression they give you when you distribute. Okay? So that's the leftover method. You find your GCF, you put it in front, and then what goes in parentheses is what's left over. Okay? So now let's take a look at letter B, and I'll show you how to do it with the box method. Okay? So letter B, I have 3x and a negative 24. So 3x is going to be 3 times x. Negative 24 is negative 2 times 3 to give me negative 6. And then 2 times 2 to give me a 4. So what do they have in common? They have a 3 in common. And that's it. They just have a 3 in common. So my GCF here is 3. Now I'm going to make my box. This is the box method. Inside my box goes my original problem, the minus 24. Outside the box goes my GCF, the 3. And now I'm looking for these missing factors. That's what I'm trying to find. So I ask myself, what do I multiply by 3 to get 3x? I multiply by x. 3 times x is 3x. I can also notice that that's also what's left over on top here. Then I look, okay, what times 3 gives me negative 24? Negative 8. And notice, negative 2 times positive 2 times positive 2 also gives me 8. So when I write my final answer is 3 times x minus 8. It's this factor times this factor. Okay, that is the box method. It doesn't matter to me which one you like to use, but you kind of can work both at the same time even, right? Like I use what's left over to help me find what's on top for the box method. Okay, so I'm going to do a few more of these with you guys, and then you're going to try some more on your own. So let's take a look here at letter E. So let's do E. So I'm first going to find my GCF. Okay, so my 6x cubed is 2 times 3 times x times x times x. Negative 8x is negative 2 times 2 times 2 times x times x. And 2x is just 2 times x. Then look for what they have in common. They have a they have a 2 in common. There is an x in common. And that is it. Just a 2 and an x. So my GCF equals 2x. Now I'm going to draw my box. Now this box is going to have 3 things inside of it, because I've got how many terms? 1, 2, 3. So I've got to make a box that has 3 terms inside of it. On the outside of my box goes my GCF, which I found to be 2x. And then I have to find these missing factors, right? That's what my goal is. So my missing factor for the top one, what times 2x gives me 6x to the third? 3 and 2x's, so 3x squared here. What times 2x gives me negative 8x squared? A 2 times a negative 2, so that's negative 4. And I've got 1x left over, so negative 4x. And then finally, on the very bottom, I don't have anything here. See how there's nothing left, but there's always an invisible 1. So when you have nothing left over, that's like having an invisible 1 here. So my final answer to this problem would be 2x, my GCF, times, because I'm trying to do this product, and I'm going to rewrite what's on top. Okay? Alright, let me box the other answers here, so that's that answer here, and answers here. Okay? Alright, let's try letter G together. Okay, I'm going to scroll down a bit. So letter G, I have 10x squared, negative 40x, and negative 50. 10x squared is 2 times 5 times x times x. Negative 40 is negative 2 times 2 to give me the 4, and then 2 times 5 to give me the 10, to get 4 times 10. Negative 50 is negative 5 times 10, but 10 is 2 times 5. So I've written them all out as my expansion. And now I'm going to find out what they have in common. So they have a 2 in common, there's a 5 in common, and that's it. Just a 2 and the 5. So my GCF is 2 times 5, which gives me 10. So now I'm going to draw my box. I have 3 terms to put inside, so I'm going to make 3. I have a 10x squared, negative 40x, and negative 50. And my GCF we just found out was 10. Now I find those missing things to put on top. So my missing things for 10x squared is 2x's, so x squared. Here I've got negative 2 and an x, so negative 2x. And here I've got a negative 5. So my final answer is going to be 10 times x squared minus 2x minus 5. All right. So what I want you guys to do now is try the other 1, 2, 3, 4, 5 problems on your own. This video is already getting kind of long, so I would like you guys to try those 5 on your own. Pause the video, try it, and then unpause and you can see the solutions. Okay? Okay, so here's all of my math work for you guys for the 4 that you tried on your own. So take a look, check to see if your answers are correct. I'm going to scroll down here in a second. Okay. So here's all of the work. Check and see what you did, what makes sense, and mark questions that you want to ask me when you see me in class for any of these problems. This is a really, really important lesson, and the fluency is pretty challenging. So take a look, pause the video if you need to. Let's spend the last 3 minutes on this video, because I know this video is pretty long already, on exercise 4. So exercise 4 says being able to fluently factor out a GCF is an essential skill. Sometimes greatest common factors are more complicated than just using monomials. We have done this type of factoring back in unit number 1. Rewrite each of the following expressions as the product of 2 binomials by factoring out a common binomial factor. So what we know when we look at this is look at what these 2 things have in common. So this is where it separates your 2 factors, this plus sign. So this x plus 5 and x plus 5, that is your GCF for something like this, because that's a factor they both have in common. When I factor out the x plus 5, what's left over is this x minus 1 here and the 2x minus 3. So this becomes x minus 1 plus 2x minus 3. Okay? And now we can simplify this. We keep the x plus 5 on the outside, but on the inside we're going to combine like terms. X plus 2x is 3x, and negative 1 minus 3 is negative 4. So now what we've done is, do we have 2 binomials? Yes. We have this is a binomial, and this is a binomial. Okay? Let's try B. B is a little trickier because now we're dealing with subtraction. Okay, see the subtraction sign? It's going to make a little difference. I still have this common factor. This 2x minus 1 is what they have in common, so I'm going to pull that out as my GCF. It is 2x minus 1. So that's my first factor. My second factor is going to be this 2x plus 7, but now instead of plus like before, I have a minus x minus 3. So I have minus x, but then minus 3, this becomes a plus 3. So that's the only tricky part, is making sure that you're watching your signs and 2 negatives make a positive. Now I have to simplify and combine like terms. 2x minus x gives me a x, and 7 plus 3 gives me a 10. So there's my binomial number 1, and there's my binomial number 2. And if you were to multiply these 2 things out, and multiply all of this out, you'd have an equivalent expression. So this is something we're working towards, is this idea, okay? I imagine a lot of you guys are going to have questions, so please don't be afraid to ask, and good luck on your fluency.